Operational energy. The power is in your hands. Operational energy is fuel, batteries, and other energy resources that our warfighters require to carry out their missions. Although they might not be aware of it, the actions of every soldier, sailor, marine, and airman can improve or degrade our ability to meet our warfighters' operational energy needs.
Energy represents an institutional challenge for the Navy. It's a $4.5 billion institutional challenge every year. And price volatility in energy has a direct impact on today's fleet readiness and our ability to train and operate globally. Energy represents a combat enabler. It's like ammunition for a weapon. The greatest challenge to improving the Navy's use of operational energy is energy command and control and metering and monitoring of energy across the entire fleet, whether for deployed Navy forces, on those destroyers and in those carrier strike groups, or for deployed Marines that are out there on the forward edge of the battlefield.
For the Marine Corps, operational energy is the energy that we use in our weapon systems. So that's our tanks, that's our aircraft, that's our fighting vehicles, it's our regular tactical vehicles, our trucks, etc. It's the energy that goes into those vehicles that lets that force get to its objective. Additionally, it's the batteries that go on the individual Marine, and it's the generators that power all the technology that enables the Marine Corps to fight the way we'd like to fight.
Operational energy is important because energy is the critical combat enabler for naval forces. Projecting combat power forward and sustaining it there requires energy at every step. Operational energy is all about being the beginning portion of the kill chain. If we don't have energy, we don't operate.
The benefit to the Marine Corps of efficient use of energy is actually all about effectiveness. It's about understanding how that energy is used and what you can do with it and how you can apply it on the battlefield to put the enemy in the horns of a dilemma, because you have that ability, that capability with you. Energy is not always going to be available, and so you need to understand where it's coming from, what it does for you, what's in it for you, and why you should care.
If we can husband our energy resources better, we can go longer, stay longer, and project combat power at a greater interval than we can today.
So the greatest challenge to improving the use of operational energy for the Marine Corps is getting Marines to understand what is operational energy, what's in it for them, and why they should care. Their behavior and their performance can increase operational reach, and then again, behavior change across the force so that they understand the importance of operational energy and they consider their energy like they consider their ammunition. They use it sparingly when necessary and they don't waste that resource.
We need to be smarter about the way we operate, and husbanding our energy resources much better and applying them in a smarter way requires a cultural change on the part of all members of the Navy.
For better or worse, mission capability is directly affected by operational energy. In a 2011 memo to all U.S. forces in Afghanistan, General David Petraeus stated that energy is the lifeblood of our warfighting capabilities. He also noted that more fuel usage means more risks for the mission, service members, and civilians. Most importantly, if military personnel use their energy smarter, they can spend less time refueling and more time fighting. As the Secretary of the Air Force, Deborah Lee James, stated, "The smart use of energy means flying our aircraft farther, transporting more cargo, and accomplishing our mission in a more efficient and effective way." When operational energy resources are used more efficiently, our forces receive a direct benefit in combat capability because more combat assets can be put toward their mission instead of logistics. Air support freed up from having to protect fuel convoys can be dedicated to combat operations. A Navy destroyer group could spend more time on station conducting operations if they didn't need to refuel as often. A fighter plane could increase its range and strike more distant targets if steps were taken to optimize fuel efficiency. The point of improving the efficiency of our operational energy usage isn't to reduce fuel consumption or to save money, but is actually to improve our capability using what we already have. This will become even more important as more energy-intensive combat systems are introduced in the future. We will always want our vehicles to go faster and our weapons to hit harder, and we must take the steps necessary to ensure that we can provide the energy required to enable those capabilities when and where we need them.
In its most base form, energy security is about having the energy to operate freely around the globe and project power where we need to. If we can do that with less fuel and hazard or provide less vulnerability to our strategic logistics force, that's the smart use of energy.
Because the capabilities of our armed forces are directly tied to our ability to produce and deliver energy resources, Energy security is absolutely vital to our national security. Energy security is the means of having assured access to reliable supplies of energy and the ability to protect and deliver sufficient energy to meet operational needs. Access to operational energy resources isn't as simple as having enough fuel or oil for a campaign sitting in a stockpile. Logistics teams must work tirelessly to ensure that these resources reach the forward fighting force when and where they're needed. Commands recognize that they can't perform their mission without access to energy resources such as fuel or electrical power. But many elements across the services have acquired a culture of energy inefficiency because they believe that they will always have access to required resources. The truth is that the logistics chain that provides these critical resources is very vulnerable, and access to energy resources is not a guarantee. Fuel and supplies must travel long distances to reach the warfighter, often through hostile areas or inhospitable terrain, and can easily encounter obstacles that delay delivery, or worse. Ensuring energy security means not only protecting the tanker ships, ground convoys, or aircraft that deliver fuel to our warfighters, but also includes safeguarding the infrastructure and industry that produce and distribute energy resources. Steps to ensure energy security at these facilities would include having redundant infrastructure and backup equipment on hand to restore operations after an attack or equipment failure. The warfighters, depending on fuel and other forms of delivered energy, can also work to use their energy more effectively and reduce their demands so that they are better able to withstand delays or disruptions in the supply chain. Operational energy must be used effectively to maximize our warfighting capabilities, because our ability to secure and deliver the energy to the warfighter is always at risk. Using our energy resources more efficiently and protecting our means of distribution allows us to reduce that risk and secure the warfighter's access to this critical combat enabler.
Some of the consequences of poorly managed operational energy are the inability to sustain combat power forward, not as long, not as persistently. We have to husband our resources because at the end of the day, if we don't have our resources, operational energy resources, the critical combat enabler, we can't sustain our operations forward.
So the consequences of poorly managing your operational energy is culmination or potential culmination. The reality is energy is not always going to be available, and the Marines need to understand where's that energy coming from, what does it do for them, and how they can make it last longer so they can be more effective in combat.
Energy efficiency is taking unprecedented priority across the services because the cost of this inefficiency is far greater than dollars. It is measured in the blood of service members. A CRS report for Congress on the Department of Defense's energy incentives referenced a 2011 quote from the Secretary of the Navy, Ray Mabus, stating, "Future adversaries can target our operational dependence on petroleum, as we see in attacks on our fuel convoys in Afghanistan." The same report explained, fuel supply lines are vulnerable to disruption from enemy attack or from natural events such as poor weather, floods, or earthquakes that can damage, destroy, or limit the use of roads, ports, and airfields. Protecting fuel supply lines against enemy attack can lead to the assignment of additional personnel and other resources to the task of moving fuel through the battlefield, increasing the diversion of resources away from other military requirements. An estimated 10% of all Marine Corps casualties and 18% of all Army casualties in Iraq and Afghanistan were related to ground resupply operations, totaling more than 3,000 U.S. troop and contractor deaths or injuries on fuel supply convoys between 2003 and 2007. Troops are placed in great danger when they are forced to transport fuel through hostile countries, but attacks on fuel convoys aren't the only casualties attributed to ineffective energy use. Guarding convoys take manpower and other resources that could instead be used to support and reduce casualties on combat operations. For example, if UAVs spend less time looking after a fuel convoy, they can spend more time supporting combat patrols. While recent casualties at sea have not been as prominent as those suffered by ground convoys in Iraq and Afghanistan, we must still consider the relations between energy use and the threats facing our sailors. While refueling, ships are tethered in a way that limits their ability to effectively defend against an attack. A recent example of this would be the attack on the USS Cole on October 12, 2000. While the USS Cole was refueling in Aden Harbor, a small fiberglass boat laden with explosives pulled up to the side of the ship and detonated, blowing a 40-foot by 60-foot gash into the side of the ship, killing 17 sailors and wounding an additional 39. Coal was later hauled back to Mississippi for repairs by the MV Blue Marlin salvage ship. By using energy at sea more efficiently, we can reduce the frequency of refueling operations and minimize the time our sailors and ships spend exposed. Fuel saved at sea could also be reallocated to extra operations to detect and protect against potential threats such as enemy submarines. Every branch of the U.S. military uses operational energy in sustaining and completing their missions. Because operational energy is such a critical mission component, the services are all working to improve their energy resiliency, with strategies promoting energy conservation, improving efficiency, or diversifying energy supplies. The Navy and Marine Corps recognize the constraints of energy on operational and tactical levels. By changing their motto from "Save energy if you can" to "Save energy unless you can't," the Navy has made significant progress with deploying efficient technologies that save energy on ships, aircrafts, submarines, and on land. One of the Navy's biggest successes has been the development of the hybrid electric drive propulsion systems for ships. After observing the success of the hybrid electric drive, the Navy has launched a program to refit the destroyer fleet with these systems at a rate of 4 ships per year. Other successes include the installation of energy-efficient LED lighting on ships, research into different means of storing energy that would otherwise go to waste, and procuring drop-in alternative fuel sources to diversify and improve the resilience of our energy resources. All of these efforts and others are making steady progress toward the goal of a Great Green Fleet. The Great Green Fleet is a year-long Navy initiative that demonstrates the Sea Service's efforts to transform its energy use. When it set sail in 2016, it set a foundation for new standards in energy use. But the Great Green Fleet and the Navy's energy goals are not focused solely on new efficient technologies. The most efficient systems in the world are of marginal value if not used properly, which highlights the distinction between energy use and energy waste. Our mission requires a certain amount of non-negotiable energy use, but there are still opportunities to cut out a tremendous amount of energy waste. That is why the Navy is working to foster culture change through programs to educate enlisted sailors and officers in proper energy management and how energy use impacts their mission. As stated before, efficient energy use can make the difference in being able to accomplish a mission. The sensors, weapons, and vehicles we rely on have no value as combat assets without the energy required to power them. This applies both at sea and ashore. The Marines are trained to fight with minimal supplies and logistics support, but are still leading efforts to further reduce the energy demands by reducing waste. By simply increasing awareness of energy use through real-time monitoring, units have seen drastic improvement in energy use through behavior change alone. At Marine Corps Base 29 Palms, they saw dramatic improvements after installing energy monitors, and are now conducting further research to explore the relation between metering and unsolicited behavior change. In one such experiment, real-time fuel consumption displays were placed in tactical vehicles, but the Marines did not receive any additional instructions or guidance. Vehicles with the fuel displays used up to 40% less fuel than those without displays. Simply making the drivers aware of their energy use was enough to bring about a significant behavior change. Out in the field, the Marines are leading the way in establishing best practices for getting the most out of new technologies that reduce the operational energy demand. They are implementing new advances in mobile power generation and efficient power distribution to reduce their energy requirements at operating bases and in the field. Because they often operate in some of the most remote and unforgiving environments, the Marines are working to ensure that these new technologies are able to perform in all climates. The Army Operational Energy Strategy states that troops are to use energy to their greatest benefit through resilient capabilities and energy-informed operations. Energy supplies are not only our greatest combat enablers, but also one of our greatest burdens and vulnerabilities. By implementing new technologies, the Army has made great progress in reducing the operational energy burden for individual soldiers in the field and for entire bases. In Afghanistan, soldiers carried nearly 14 pounds of replacement batteries to power individual equipment on 72-hour missions. But by improving battery technology, we have saved 4.2 pounds in batteries that could be used for more ammo or other equipment instead. New technologies like the Integrated Soldier Power and Data System have further reduced battery weight by integrating systems that efficiently manage power distribution to equipment or charge batteries by harvesting kinetic energy from the soldiers' movements. At forward operating bases, operational energy initiatives include fielding of advanced medium mobile power sources to Afghanistan, The new generators use 21% less fuel than older systems. Operational testing of a JP8 powered 1 kilowatt generator, a JP8 powered 1 kilowatt fuel cell, a modular universal battery charger, and microgrids are further reducing both the types and the amount of fuel required in theater. In conventional operating base configurations, each building was tied to its own generator. With microgrids, however, much less energy and fuel is wasted because extra generators are shut off if they are not needed, which also reduces required maintenance. Adding alternative energy sources, battery storage, and gray water recycling can further reduce a base's dependence on delivered energy and water. Some forward operating bases in Afghanistan need aerial resupply every 3 days, with fuel and water making up 70% of the cargo. By providing the base with the means to better produce and manage energy and water, resupply was reduced to once every 10 days. With microgrids, there are fewer trucks on the road and less force protection is needed, so commanders have more assets to put against combat missions. The Assistant Secretary of the Air Force, Installations, Environment and Energy, Miranda Ballantine, remarked that the Air Force is actively working on making aviation energy more efficient, more affordable, and getting more mission out of every gallon of jet fuel. Additionally, she commented on the importance of energy, stating, "Without energy, we do not have a mission." Air Force Title X War Games, United Engagement 2014, and Future Games 2015 each identified energy as a significant constraint when conducting major combat operations. Resulting analysis of these and other war games led to development of commercial supply chain and partner nation capability in the Pacific and other areas. In efforts to become more energy efficient, the Air Force has begun training pilots to be more energy conscious, redesigning air refueling tracks and airdrop training, optimizing their use of airspace, changing flying variables such as airspeed and altitude to optimize fuel usage. The Air Force has also rolled out the Airmen Powered by Innovation program, which aims to change individual behaviors through training, emphasizing optimal altitude and speed in simulations, and through modeling industry best practices. New fuel-efficient technologies are also being pursued, such as the Adaptive Engine Transition Program for combat aircraft. These new engines are expected to produce greater thrust while being 25% more fuel efficient.
Individual service members play an important role in operational energy use and operational energy awareness. Every sailor, every officer on the deck plates, every Marine for that matter, aboard any Navy ship, has the ability to understand how we use energy and to come up with good and better ideas about how to employ that energy while we're operating.
So what can you do as an individual service member? You can avoid using energy unnecessarily. Minimize your idling, turn off the engine if not in motion for more than 5 minutes. Use natural lighting. Not only is it efficient task lighting, but it is also scientifically proven that natural light increases productivity more than some light bulbs. Unplug your chargers when not in use. Chargers still use energy when plugged into outlets, even if they're not powering anything. Read up on emerging technologies or new energy developments and bring them to the attention of your commands. Encourage energy conservation within your unit through incentives or competitions. Encourage a culture of efficient and sustainable energy use. Remind your peers that the energy and water are mission-critical resources and every little bit helps. Identify incidents where available energy resources would have directly impacted those around you. For example, a squad on patrol might have received extra support if other assets weren't committed to guarding a fuel convoy. Be conscious of how much energy you and your command are using, and encourage others to do the same. You can reach out to your command to educate them on the possible means of improving our energy security and the potential benefits of using our operational energy resources more efficiently. Raise awareness for the different operational limitations you face because of available energy resources, so your command will understand the impact of operational energy use and include these concerns in future decision-making. Identify equipment or practices that waste or use energy inefficiently, so your command will recognize the potential for improved efficiency and identify areas with the greatest potential for improvement. Advocate for the implementation of the renewable or efficient energy technologies that are available to you, such as microgrids or solar power arrays. Show your command how these systems will improve their energy resiliency and free up manpower and resources for other mission-critical tasks. Keep your command up to date on energy technology developments so that they can consider these technologies for future integration. Work with your command to incentivize efficient energy use behaviors through competitions or rewards. Energy is our greatest enabler and our greatest vulnerability. It is what fuels our troops on and off the battlefield. By saving energy and using energy efficiently, you can make a difference that is measured in both dollars and lives. Our mission depends on our ability to manage our energy, and our ability to manage our energy starts with you. The power is in your hands. For more information on operational energy, visit our Joint Energy Education community page on JKO that serves as a comprehensive repository for energy courses, policy, doctrine, and educational materials. Service members and DoD civilians who wish to learn even more about operational energy and its specific applications in the armed forces, DoD, academia, and industry are encouraged to reach out to the Naval Postgraduate School's Energy Academic Group. For information regarding energy-focused graduate programs, distance learning courses, and seminars covering a wide variety of valuable energy topics and their importance in national defense.